vertex form equations. We're going to look in this video at plotting quadratic equations using vertex form, so we can figure out very quickly and easily where the vertex is. We're going to use Desmos. I'm going to start with my basic quadratic, y equals x squared, and we're going to have a look at the graph. The vertex is at point 0, 0, and if you notice, as I go 1 unit to the right, I go up 1 unit. It's symmetric, so 1 unit to the left goes up 1 unit as well. If I go to the 2 units to the right, then the graph goes up to 4. And again on the left, 2 units to the left, the graph goes up to 4. I can move this graph around. One of the easiest ways I can move it around is by adding a number to it. If I add 2, it moves it up to intercept here on the y-axis at +2. Similarly, if I make that -1, then it intercepts down here at y equals -1. But it's the shift in x that's the most confusing. So think about it like this. I'm going to isolate my x before I square it, and inside that parenthesis I'm going to put -1. See if you can figure out what's going to happen to my graph. Alright, it moved it to the right. So moving the graph to the right by adding a -1 with the x can be a little bit confusing to people. Let me get rid of this -1 and let's explain why. Why does putting the -1 move the graph to the right? Well, at this point here, I'm looking for the 0. I'm looking for the value that gives my, let's just turn this one off. I'm looking for the value that gives my graph a 0 in y, and that happens when this whole bracket is 0. Obviously my y is 0 when x -1 is 0, and that happens when x equals +1. So the graph kind of responds in the opposite way that you might think. If I change it to x +1, this bracket has a 0 when x equals -1. And you can see if I put a slider in here, as I move the slider to the left, the graph goes to the right. As I move the slider to the right, the graph goes to the left. So the graph kind of does the opposite because we're always solving for when this bracket is 0. If I add a slider for the b, you can see that the b, if I move it up to the right, the graph goes up, and move it to the left, the graph goes down. You might be confused as to, well, how do you remember this? The +b, the graph kind of does the thing you expect it to do. A positive value of b moves it up. But inside the bracket, it kind of does the opposite. Well, it's because I've separated the shift in b, the b shift from the y. Let's see if I can do it. If I move it to the other side of the bracket, what it becomes is, if I put it was y plus b over here, now as I move the b slider left, the graph goes up, and move it down, the graph, so to move it down I have to move the slider to the right. So you can see that when it's with the variable, the slider makes the graph kind of do the opposite thing, making b bigger now, moves the graph down. So that hopefully, I don't know if that cleared it up. Maybe it made it more confusing, who knows. But really the +b goes here. So this is vertex form, and that's all there is to it, except for one thing. There is a slight modification I want you to think of as well. If I put a capital A now, this is a value that I'm going to multiply my graph by, and it's going to change the shape of the graph. Notice moving capital A doesn't change where the vertex is, but it makes the graph change shape. A high value of A makes the graph tall and skinny. If I move A all the way up to 10, you can see that it makes this graph very narrow, but really it makes it very tall. If I bring these values back to 0, now if I go 1 unit to the right, instead of going 1 unit up, see I'm zooming, I go 10 units up. Okay, so that's why this A value makes it looks skinny. If I bring the a value down to something that's less than 1, maybe 0.2, I can get 0.1 is good, then instead of going 1 unit to the right and 1 unit up, I go 1 unit to the right and 0.1 unit up. So it makes the graph look very wide, but of course it looks wide because it's being squashed down in the y direction. So that's vertex form. The capital A changes the shape of the graph. These values here change the point of the vertex, and because these values little a and little b are directly linked to the coordinates of the vertex, that's why we call it vertex form. Thanks for watching.